You travel by boat upstream against the current 10 miles in 2 hours. Then you turn around and you head back downstream with the current in 1 hour. What is the speed of the boat in still water, and what is the current speed? Okay, so this is a typical problem, probably one that you're experiencing in your math class, and you're just wondering, how to do these types of problems. Well, one thing I want to mention is that when you're going against the current, okay, this way, the current's slowing you down. You're trying to go this way, the current's pushing against you, so it's taking away from your speed. And then when you're going with the current's actually pushing you along. It's helping you, it's increasing your speed, right? So that's something we want to pay attention to. The other thing we want to pay attention to is that the formula distance equals rate times time. All I did was just change the left and right sides. I just flipped it over. So rate times time equals distance. I like to make a chart like this just to organize my information. And I'm going to divide this up into when you're going against the current and then when you're going with the current. So when you're going against the current, let's just say that B is the speed of the boat in still water. We're going to subtract the current speed because it's opposing you, and we're traveling for 2 hours and we're going a distance of 10 miles. So I'm just filling in the chart as much as I know. Now when you're going with the current, you take this boat speed, which we don't know what it is, so we're just giving it a variable B. We're adding the current because it's pushing you along, and that only takes 1 hour now to travel the 10 miles back. So now you can see we have two equations, a system of equations we can use to solve for B and C. So I'm just going to go ahead and simplify a little bit further here by distributing, because it's rate times time. So if I distribute, I get 2B minus 2C equals 10. And here if I distribute the 1, I just get B plus C equals 10. So we're going to use the elimination method. We're going to combine these two equations together. I'm going to multiply the bottom equation by negative 2. So that gives you negative 2b minus 2c equals negative 20. So I'm going to add these two equations together. The b's are going to cancel. We get negative 4c equals negative 10. And if I divide by negative 4, c equals negative 10 fourths. Okay, negative 10 over negative 4, which is 5 halves. Okay, right? Which equals 2 1/2. Okay, or 2.5. And what that means is that the speed of the current is 2.5 miles per hour. Now, if you take that 2.5, you put it back into any one of these equations for C, I'll just put it into this one here since it's the simplest. We have B plus the current, which is 2.5, equals 10. If we subtract, we get the boat speed is 7.5 miles per hour. So that's it. Pretty easy, right? So you're just going with the current. That's B plus C. Against the current, B minus C. And if you organize your information in a table like this, that'll help you to write your two equations, and then you can solve the system. So this completes the three-part series. We're talking about distance traveled. Go ahead and check out these other videos if you haven't seen them. Subscribe to the channel, and I'll talk to you in the future videos. I'll talk to you soon.